Hey there, everybody. Time to talk about our Fruit Pizza Forum, Session 5 of Unit 7, Module 1. So, we're just going to discuss a little bit. We're going to check over your answers for our math forum, get you to think a little bit about it. So, go ahead and open up your books to page 261. Remember, those are the pages, or that is the page that you figured out how many cups of fruit went on each pizza. And then we have a little problem string working out some equivalent ratios. And then when we're all done, you do your student book page 263. All right, so now before we get started, let's take a look at what you had to do for your homework. Remember, homework was page 262 in your student book, and your home connections, page 135 and 136. So there is page 262. Go ahead and stop the video and check over your answers. If you have any questions, please reach out to your teacher so that you have so that you can get your questions answered as quick as possible. Here are your answers for your home connections, page 135 and 136. Remember, if it says answers will vary, that means that you can solve the problem just using a different way. So no worries if you don't match up exactly the way that our answer key does. All right, so now I'm going to ask you to get out your page 261 of your student book. Let's take a look at your answers. Here are the correct answers for how many cups of fruit go on each one of our pizzas. Okay, do you notice any similarities? What differences do you notice? I think the hardest ones might have been to come up with the kiwi and the mandarin orange. Um, that just because we're working with fractions and a remainder. So hopefully you figured out that the remainder over the whole number or the divisor reduced down equaled 1/2. All right. Well, for me, I noticed that strawberries, blackberries, raspberries, grapes, and pineapple all took 4 cups of fruit per pizza. And I have that over here on our little ratio type table here, right? So I want you to kind of look at where each one of our pizzas are 4-to-1 in a ratio, right? 4 cups of fruit to 1 pizza, and how we're able to figure out pineapples from that, right? So if I divide my pineapple by, or if I divide my cups by 2 and I divide my pizza in half, that would be 2 cups for a half a pizza, which would be equal, right? Because that's how ratio tables work. As long as you go up and down and you multiply or divide by the same number, you have an equal ratio. Again, if we look at the grapes, if we have 1 cup of fruit for grapes, that equals 1/4 of a pizza, right? Because we're dividing the 1 by 4. And the other way around, if we are taking our 4 and we're going to 188, that we can realize that 4 goes into 88 22 times. So 1 times 22 is 22 pizzas. So if we have 88 raspberries, we can make 22 pizzas. All right, and so on. Make sure that the use of ratio tables is real important when we're doing this. It's a real convenient and easy way for us to kind of look at things, which we're going to be doing work with problem strings today and ratio tables. All right, so you can go ahead and put away your number corner book, or I'm sorry, your student book, and then we will get out a notebook or a piece of paper so that we can do a problem string. So our problem string deals with equivalent ratios. So let's take a look at the first problem. It says, if a student ran 4 miles in 20 minutes, how fast was she running and what was her pace per mile? Okay, now you might have already been able to figure it out, but let's go ahead and take a look on how that would look in a ratio table form, right? So we have 4, and I'm just going to use the capital letter I to I'm going to use my capital letter I to divide up my ratios. And then I have 20 for my bottom ratio. So if we're running 4 miles in 20 minutes, I want to figure out how fast she runs in 1 mile. So look at what I'm doing to my numerator or my top number to get to 1. I am doing what? I'm dividing by 4. So I have to divide 20 by 4 and I get 5, right? So my answer would be I run 1 mile in 5 minutes. That's pretty good pace. It'd be about twice as fast as I could run, really. Okay, now we're going to do the same thing with the next one, right? If a student ran 2 miles in 20 minutes, how fast was he running? Go ahead and set up your paper just like I just did. We're going to put the 2 on top. And we are going to put the 20 on the bottom. So how fast would he run per mile? Because we're figuring out per mile, we're dividing by we're trying to figure out how fast he will run in 1 mile. So what am I doing to the 2 to get 1? I'm dividing it in half. So I'm dividing by 2. So I have to divide the 20 by 2 and get 10. Did you get that answer? I hope so. All right, next one. If a student ran 8 miles in 40 minutes, how fast was he or she running per mile? Right? So I do my 8 and I do my 40 on the bottom of my ratio table. And now consider we want 1 mile. So if we broke that down, how would we figure that out? Well, we have to, from 8 to 1, what do we have to do? We have to divide by 8, right? So which means we have to do that to our bottom part of our ratio. So what is 8 divided by, or 40 divided by 8? It's 5, right? I can also look up here, right? This could kind of give me a little bit of help with 4 goes into 8 twice and 20 goes into 40 twice. So it will equal the same ratio if I want to use previous work to help me. All right, so there's somebody walking in my house. If a student ran 3 miles in 30 minutes, how fast would he be running per mile, right? That looks very similar to my 2 and 20. So I'll have my 3 up on top and, no, I don't want another 3 up on top and my 30 on the bottom of my ratio table. And I want to figure out the speed per mile. Okay, so what am I doing to the 3 to get 1? I'm dividing by 3, right? So I have to divide my 30 by 3, and what does that give me? 10. Yes. So these are more my pace. Actually, it could probably be a little bit slower, but that's the way that I run. I tend to like to walk a little bit more. All right. So now let's take a look at this. If a student was walking a half a mile in 30 minutes, see, that's my more pace. I have a half a mile, right, in 30 minutes. So I have to divide 30 by a half. And remember not to use the tab key, right? So if I'm keeping on that same ratio, how fast am I working per mile? Well, what am I doing here? I have 1 mile. So what do I have to do to the half to get 1 whole? I have to multiply by 2, right? I'm not dividing this time. I have to multiply. So then I got to multiply my 30 by 2. And what do I get? 60. Awesome. Good work. All right. Our next one says we got 1/4 of a mile in walking. This is my problem string. We have 1/4 of a mile, and we do that. Oh no, we don't want to do that, but I do want to get on the end and enter. We got 1/4 of a mile, and we do that in 5 minutes. So what would that be, right? So how many fourths in 1 whole? 4. So if I'm multiplying 1/4 by 4, I get 1. So I have in a ratio table, I have to do the same thing on the bottom. So I'm just going to try to limit the size of our tables. So I have to multiply my bottom ratio number by 4, and I get 20. So this is a little faster than my half a mile in 30 minutes, right? All right, so let's go ahead and switch over to our next one. It says if a student walked 1/4 of a mile in 8 minutes, how fast was he walking per mile? Well, we know that when we multiply 1/4 of a mile by 4, we get 1, right? So we have to multiply our bottom number, 8, by 4, and we get 32, right? So it takes us 32 minutes to walk 1 mile. All right, good. Now let's take a look at our next one. We have 1/5 of a mile in 5 miles, or in 5 minutes. So I'll take my fraction 1/5, and I do know that for me to go 1 mile, right, I have to walk 1/5 5 times, and that would give me my equivalent ratio. So I then multiply my 5 by 5, and I get 25 minutes. Pretty cool, right? All right, we got one more here, and we'll solve this problem together, and then we'll be all done for today. All right, so let's take a look at, we have 1/10 of a mile. Ooh. And we do it in a minute. So what are we doing with 1/10 of a mile? What do I have to do to get to 1 mile? Right, I have to run 1/10 of a mile to get to a mile. So that would mean that I would need, and I did this on the last problem, 1 minute. So then it would take me, because I have to multiply my top number by 10, I have to multiply my bottom number by 10, and that gives me 10 minutes. All right. Hopefully you all understand this. Just using a simple ratio table will help us with our division, right? And help us with our multiplication and division of fractions. So if you have any questions on this, go ahead and reach out to your teachers, and they'll be more than happy to get in contact with you and help you wherever you need that help. If you don't need any help, open up your student book to page 263, finish page 263, and then you're done for the day. So hopefully everything's going well, and I hope it is. So keep enjoying math.